Algebra challenge problem. Let's solve it step by step together. The first step is to notice that 8 is the cube of 2. Using laws of indices, we can swap the 3 and x, and this becomes a cubic equation because if we let some y be 2 to the x, then the equation becomes y cubed plus y minus 130 equals 0. To factor this cubic, we'll use the rational root theorem. Let's check factors of this constant term. 1, -1, 2, -2 are too small to give us 0 when plugged in, and factors like 10, 65, and 130 are way too big. If we check y equals 5, we get 125 plus 5, which is 130, minus 130 is indeed 0, so this checks out. The factor theorem tells us that y minus 5 therefore must be a factor. But we still have a quadratic to find. So how do we get this missing factor? For this, we'll use long division. So let's set up the dividend, the divisor, and looking at the leading terms, we see we must multiply by y squared. Doing so and subtracting the result gives 5y squared plus y minus 130. We now need to multiply by 5y. Doing so and subtracting, we get 26y minus 130. Finally, we multiply by 26 and we get a remainder of 0 as expected because we know the cubic is divisible by y minus 5. So we now know that the quadratic we set out to find is this y squared plus 5y plus 26. Now then, the solution to this equation is either y minus 5, meaning y equals 5, or the quadratic must be equal to 0. But if we look at the discriminant, b squared minus 4ac, it gives us negative 79, a negative number, meaning that this has no real solutions. And so y equals 5 is the only real root of this cubic. Now, y was 2 to the x, remember? So if 2 to the x is equal to 5, then x itself is log base 2 of 5, or the ratio of logs base 10, or the ratio of natural logs, whichever way you like to express it. Ultimately, the answer is approximately 2.322. And that completes the problem.